question we had was number 8. So we are solving this exponential. Remember, common bases are still going to pop up periodically. I think, which question? There's like number 9, you could have gotten a common base on this one. You didn't have to do it that way. Logs always work, they just take longer. But if you can't get a common base, that's when you add a log to each side. Now, when we have ease, what kind of log is nicest? Doesn't mean you have to do it, it just makes it a little bit nicer as we go through. Okay, properties of logs. When you have a natural log and an e, what happens to that? They cancel. And the exponent comes down. So that's why the natural log was so nice here. In this one, the x comes down, so we just have natural log of 5. I'm trying to solve for x, and I have it in 2 spots, so I need to get those on the same side. So I can add over my 4x. They aren't like terms, we can't actually add them, so what can we do? So it's x times that, so to get x by itself, we divide. So it's -1 over the natural log of 5 plus 4. Make sure you know how to put these in your calculator. Okay, I want you to be able to give me the decimal equivalents. So this is -0.1783. We did not ask about anything else on the first page. Are there any others there? 9. So on Friday when we were working on this, I noticed most people adding logs, which certainly works, but look at your bases. 8 and 4, what could you do on those? Common base. 8 is 2 to the 3rd. 4 is 2 squared. So we get 2 to the 18 plus 9x equals 2 squared. So 9x equals -16. So -16 over 9. Or if you divide those, you get -1.7 repeating. The other option, you add a log to each side, bring down your exponent, and get x by itself. Anything else on the first page? Number 12. This one was just not very pretty. Any problem starting with logs, we have to begin by trying to condense. If I have 2 logs subtracted, how do I put them together? X squared over 7. Okay. My log problem, there's one of 2 options after this point. You condense any logs you can. Either there's a log on both sides and you can drop it, or if it's only on one side, what do we do? Yeah. This is the definition of a log. We rewrite it in that exponential form. So that means 3 to the 12th power is equal to x squared over 7. So multiply over our 7. This is a massive number. How do we get rid of a square? With that, you would do plus and minus, but we can't have negative arguments, so it's just the positive. And so we get 1,928.7527. I feel like that may have been a typo. I might have meant to put equal to 2 instead of 12, but we could still solve it. Just gave some big numbers. Problem 13. We start with properties of logs. On the left, we already just have a single log. On the right, we have a single log, but the problem is there is a 2 in front. So what should I do with that 2? Now, this problem has a log on each side. What happens if there's a log on each side? Okay, it's a quadratic, so we could set it equal to 0. So subtract the 7x and add the 12. What multiplies to negative 7 and adds to, multiplies to positive 12 and adds to negative 7? Okay. Set those equal to 0 and we get 3 and 4. Remember, any problem that starts with a log, you have to check. And all you're verifying is, if I put this in, do I get a positive number? So 7 times 3 is 21, minus 12 is positive. 28 minus 12 is also positive. So both answers work here. Right. So the log problems, you always start with the properties of logs, condensing as much as possible. Then there's one of 2 options. Either there's a log on one side or a log on both sides. So when I look at this one, I have 2 logs over here. If they are added, how do I put them together? Boil that out. Now there's a log on one side. If it's on one side, how do I get rid of the log? Exponential. So this is 2 to the first plus x squared, 7x plus 12. 2 to the first is just 2, so you can bring that over. What multiplies to 10 and adds to 7? If we set those equal to 0, we get negative 5 and negative 2. But we always check. If I put in negative 5 plus 3 is not positive, so that one won't work. Negative 2 plus 3 is positive, negative 2 plus 4 is positive, so that one is okay. So negative 2 is the only answer. Are we okay on that? Problem 15. Start by using the properties to simplify. If you have 2 logs added, how do we put them together? So if you distribute that x, you get x squared minus 2x. All right, on the right-hand side, I only have a single log, so that comes down. Now I have 1 log on each side. What does that mean? And then what? So if we bring over to x, bring over to 4, so we have it equal to 0. Multiply to negative 4, add to negative 3. Negative 4 and positive 1. Set those equal to 0, and we get 4 and negative 1. Check. 4 is positive, 4 minus 2 is positive, 4 plus 4 is positive, so that one's good. If I put in negative 1 is not positive, so that one's out. 4 is my only answer. Is everybody fixing any mistakes that they have right now? Okay, paying attention, since we haven't done this since Friday, we have a test coming up. Are we making sure we're asking the questions as I go through these problems? So problem 16, where do I begin? Yes. Alright, so if logs are subtracted, how do I condense them? Okay, same thing on this side. Now I have one log on each side. What does that mean? Mhm. Good. How do we solve this? Cross multiply. You have to FOIL out as you do that. So, if I multiply these, we get x squared plus 2x minus 3. If I multiply those, we get x squared plus 4x minus 12. If I subtract my x squared, it's actually kind of nice because those cancel out, so now it's just linear. If I bring over my 4x, bring over my 3, get negative 2x equals negative 9. Divide, and that's 9/2, or 4.5. Check it. 4.5 minus 1 plus 6 minus 2 plus 3, all of those are positive, so that answer works. Alright, so we just worked through all of the log equations. Always condense first, then either drop the logs if it's on both sides, or change the exponential if it's only on one. You guys okay back there? Problem 17. I said you must show work on the test. If you don't show work, you get no points on this question. The change of base formula, that's just log over log. But you do log of the big number divided by log of the small number. Okay? If you forget, you could always set it equal to x and solve it like that. Then when I type this in, just make sure you close your parentheses after your logs. So we get 2.1534. So you have to have that one. Alright, problem number 18. How many years will it take for an initial investment of $25,000? What does that number represent? P. It's our starting amount. To grow to 80,000, so that is my. Assuming a rate of 7%, so what do I use for R? Compounded continuously, so that means we're doing A equals PE to RT. So we have 80,000 equals 25,000 E to the 0.07T. All right, what do I have to do to get the T by itself? So if I divide the 25,000, I get 3.2 equals E to the 0.07T. Trying to solve for my exponent, I can't get a common base, so what do I do? Okay. So I have the natural log of 3.2. Over here, exponent comes down. And the natural log of E just cancels out, so that's gone. So we divide the 0.07. We get 16.6164 or 16.6 years. $19 is similar, except this one wasn't continuous compounding. So we're using the other formula. Find the doubling time of an investment compounded semi-annually. What does that mean? 2 times. So that's my N. At a rate of 3%. So R would be Doubling time is the time until it doubles. I did not tell you how much we started with, so you can pick any amount you want. What do you guys want to start with? So 10, and we end with 20. Okay? So if we plug in, divide our 10, we get 2. 1 plus 0.03 divided by 2, 1.015. All right, we can't get a common base here, so what do we do? Okay, the benefit of that is properties of logs, the exponent comes down. So now you're going to divide. So we have log 2, we're going to divide by 2, log 1.015. And that gives us 23.277 or 23.3 years. What questions do we have there? All right, last few. 20, we are expanding, so using our properties of logs to break things apart. Remember, we can break apart multiplication and division, but not addition and subtraction. So on the top, I have two things multiplied, so we do the log of each added together. On the bottom, since it's on the bottom, we subtract, and we have this whole thing. Can I separate the x cubed minus 1? No, because it's subtraction. Can I bring my 3 in front? Only if it's the entire thing to the third power. So if it was like this, it would come in front. Since it's not, it's only on the x, and we can't get rid of that minus 1, we just have to leave it like that. Unless you wanted to like use your cube formula to factor x cubed minus 1, I guess you could do that if you like, but wouldn't be necessary. 22. These problems are actually not complicated, but you have to know what the domain of a log is. And if you think about it, you do know, because on every problem that started with a log, I told you to check your answers. And what are you checking for? Whatever we're doing the log of has to be greater than 0, right? So when I'm looking at these, I just have to take whatever's in my parentheses greater than 0. Okay, it doesn't matter if there's anything on the outside, it's just the argument greater than 0. So if we solve, x is greater than 3/2, so bigger than 3/2 would be 3/2 to infinity. This one, if I solve, I subtract my 8. What happens when you divide by a negative? So I get x is less than 8/5. If you're less than, it's smaller, so that would be negative infinity to 8/5. So domain, just whatever's in your parentheses greater than 0. And 24. All right, if we are graphing a log, we always start out changing it to exponential form. So this means 4 to the y equals x. Then we made a t-chart. Since y is the exponent, it's just like graphing an exponential, we always put in -1, 0, and 1 for the exponent. Y is the exponent, so that's my -1, 0, and 1. What is 4 to the -1 power? 0.25 or 1/4. 4 to the 0 power. Anything to the 0 power is 1. 4 to the first. 1/4, -1, 1, 0, 4, 1. Remember, all of these have an asymptote. It's the y-axis here, because we know the argument is greater than 0. So your graph should look like that. So on B, can I write that in exponential form? That means 1/4 to the y is equal to x. So we make our t-chart. Put in -1, 0, and 1 for the y. 1/4 to the -1, 4. 1/4 to the 0, and 1/4 to the first. -1, 1, 0, 1/4, 1. Again, your asymptote. You have a vertical asymptote at the y-axis, so make sure you aren't crossing over that. And it should look like this. Are we okay with this? On C, I would expect a parent function. It is a log base 4. So my parent function is what we graphed on part A. So we had the points 1/4, -1, 1, 0, 4, 1. Now, think about transformations. What does a +1 do? So I'm taking each of these points to the left one. What else do I have to remember when I do that? The asymptote. It was on the y-axis. If I moved it to the left, it's now at -1. You have to draw that in. And then we can draw our graph approaching that line.
Make it 1.
Right. Start by condensing on the left. Because those logs are subtracted, we put them together with division. And then what do we do? So we can multiply the 3 over. Subtract my 3, subtract my x. Divide by 20, and we get 1/5. Or 1/6.
I thought you couldn't do that since it wasn't like 10. Yeah, I don't even think you could do that.
You're thinking like adding and subtracting. All right, and then when we check it, the argument has to be positive, which it is, so that answer works. All right, number 2. What did you do first? Condense. We only have one log on the left. On the right, how do I put those together? Multiply. So 2 times 2x plus 3 would give me 4x plus 6. Now there's a log on each side, so we drop it. Subtract over my 4x. Subtract my 1. Did you guys get 5 for your answer? And when we check it, that one does work. All right, the third one. What do I do first? condensed, since those logs are added, we multiply their arguments, so x squared plus 5x. Now, this is different than the other two, because the log is only on one side. What do we do? 6 squared is 36. Multiply to negative 36, add to positive 5. Set those to 0 and we get 4 and negative 9. When we check, arguments have to be positive. Are both of those okay? No. Negative 9 does not work, so 4 is our only answer. Is that okay? I think we still have a calculator? I thought it was supposed to be quit by now. Let's do a couple exponential problems and we'll probably stop for today. What if I said do these two. This will be add a log to each side. Can I go ahead and drop down my exponent? Is that okay? So the 1 minus 2x comes down. Over here, the x comes down. What do I need to do on the left? So I get log 3 minus 2x log 3 equals x log 5. So we put all the x terms on the same side. And then what do we do? So we have x times something, so we divide. So it's log 3 divided by log 5 plus 2 log 3. So if I plug that in, we get 0.2886. How did you do on that one? Number 2. Can I take this 0.5 times 8? Order of operations says I have to do exponents before I multiply. So what do I do with it instead? Divide it. So 0.3 divided by 0.5, you can write it as, you can leave it like that, you can write it as 3 fish, you can write it as 0.6, it doesn't matter. Now what do we have to do? When we do that, exponent comes down. So to get x by itself, we divide by the 0.3 log of 8. All right. Any questions there?